We have an air conditioner from a very famous brand, but the EC error code appearing on it is actually from a TCL PCB, not the original PCB of this well-known brand. That's why we are showing you the TCL error code so that we can explain the meaning of this error. This error code shows up only when there is a problem with the outdoor unit. Otherwise, it will not be displayed. At the moment, you can see that the outdoor blower motor is running and working properly. However, the compressor is not starting, even though electricity is being supplied and the unit is operational. But despite this, an error is still being displayed. Now let's check how many error blinks are appearing. We need to count the blinks carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 blinks in total. This indicates that there is an issue with the PCBs. Let me show you the two PCBs installed here. One is the PFC PCB and the other is the IPM PCB. The indicator lights on both of these PCBs are not blinking, which means that neither of these PCBs is functioning properly. So let's now inspect what the problem could be in these PCBs. So now let's remove this PCB and place it on the table. We will provide you with complete information about what the issue is with these PCBs. As you saw, the LED 401 is blinking 15 times and the indoor unit is showing an EC error. This means that there is no communication between the power PCB, the PFC circuit, and IPM PCB. The first possible cause of this fault could be a loose connection. Look at connector number 5. If this connector is not properly connected or has a loose connection, this error can occur. What you should do is remove the connector because sometimes, due to vibrations from the unit, the wires can become loose. Additionally, rust can accumulate on the connector pins, which can disrupt the electrical connection. A good practice is to remove the connector, clean the wires, and slightly move them back and forth before reconnecting it. This ensures a firm and proper connection. Another possible cause is if the wire in the middle gets cut or damaged, which can also lead to this issue. These wires directly connect to the IPM PCB and also communicate with the PFC PCB. So if there is a problem in the connection or communication between these PCBs, this type of issue can arise. Now, let me also tell you that there are certain voltage points mentioned on the PCB. If you check these voltages relative to the ground, you will get an idea of where the problem might be. Check the 15 volts with ground, as well as the VCC. By measuring these points, you will be able to understand what is the situation of the circuit board. Now let me explain the possible issues that can occur in the PFC and IPM PCBs. If we take a look at the PFC PCB, we can see that a complete rectification system is present here. It includes components like IGBTs and diodes. Since the power PCB is working, this confirms that the rectification system, IGBT and diodes are all in good condition and there is no issue with them. So, what should we check next? If there is a fault in the microcontroller, the PCB will be completely dead, and in that case, the only option would be to replace the PFC PCB. Another possible issue is with the voltage regulator. This board has a 5-volt voltage regulator, L7805CV3. If this regulator becomes faulty, it will prevent the PFC PCB from receiving the proper supply voltage. As a result, the microcontroller will also not function, and the communication with the other PCBs will be interrupted. If any small component like a resistor or capacitor becomes faulty, it will require checking each point one by one to identify the issue. However, at this point, we have confirmed that the rectification system, IGBT, and diodes are all working properly, so we can rule them out as the source of the problem. Now, let's talk about the PFC PCB. You can see that wires are connected to it, and one important thing to note here is that you should check for VCC and ground. If you get 5 volts between VCC and ground, it means that this part of the system is working correctly. However, since this PCB has a slightly different voltage system, you need to pay close attention. Generally, the possibility of the IPM PCB being faulty is low because the issue is related to communication, but there is still a chance that it could have a short circuit. This type of short circuit is often not visible, and you may only detect it using a multimeter, but the chance of this being the issue is low. The IPM PCB works on 3.3 volts, and its microcontroller also operates at 3.3 volts. To achieve this, a 3.3 volt voltage regulator is used on the PCB. Let me zoom in on it. You can see that this is the 3.3 volts voltage regulator. If this regulator fails, then the microcontroller will stop working entirely and there will be no communication. To diagnose this, you should first check the voltage regulators on both the PFC and IPM PCBs. If they are providing proper voltages, then the problem might be with one of the small components on the PCB. However, if the microcontroller itself is faulty, it will be nearly impossible to repair, and the only option would be to replace the PCB. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.